started recording.
Thank you, sir.
So guys, this paper, this one we're working, won't count for marks. So the idea is that you can try, you can make mistakes, you can mess this picture up, as long as you understand what happens now with mechanical assembly. So last year, our focus was mainly on understanding the here the idea is that you have to assemble a machine or part of a machine with different components, showing it from different views. And you cut it in half, maybe. So I'll show you what I mean. So let's first just read the question. Right, so what they give you is an exploded isometric drawing of the parts of a pulley. Now, it's not really exploded. There's not a bomb on this page. What they mean is they gave you in 3D, that's what isometric means, how the machine, this pulley, fits into one another. Okay, so as you can see, there's a shaft. Then you fit this component over it, the bush over the shaft, the pulley, and then the washer and the nut that keeps it in place. And this makes up one entire machine or mechanical object. Right, next. Okay, showing the relative positions. What they also give you is an orthographic views of each of the parts. So they give it to you in 3D, but they also give it to you in 2D from different angles. Now here's the question. This is the nut, but is this the front view or is this the front view? Or is this the side view? How do we know which view? So it's two views of the same component, but how do we know which one is which? Go back to your exploded view. The question has to tell you which way is the front view. So according to this question, the front view faces that way. So that means, I will get this. This is the front view. Then this side should be the left view. We can't see the right view because it's at the back, and you can't see the back view because it's also at the back. So the only two views they can actually ask us is front and left. So that's why, but usually they give you two views. So let's read what we have to do. This is what they gave us. What do they want us to do? So answer the question on page 7. Draw to scale 2:1. Let's stop there. Let's quickly just confirm again what 2:1 means. 2:1, I'm going to translate it, means 2/1, and 2 divided by 1 equals 2. So this means all the measurements must be multiplied by 2. Okay. So draw to scale 2:1, in third angle orthographic projection. Mechanical will always be done in third angle, which just means if you draw a left view, it's on the left side of the front view. If you draw a top view, it has to be above the front view. Your front view is always your starting point, and we go from there. Okay, so draw this pulley assembly, and the only view they want is one view, a sectional front view. Sectional means it's cut. Where is it cut? On cutting plane AA. Let's look for cutting plane AA. It should be given to you somewhere on one of the components. Let's see.
The top right, sir.
Top right. Yeah, we go. Thank you. There. So according to this picture, this pulley is going to be cut in half, exactly halfway. So it's almost like if this was a piece of cake, the front part will be removed. Okay, so they want a sectional front view. And that's the only view they want. Sometimes usually they ask for two views. Today, just to start off, we're going to start off one view. Okay, as seen from the direction of the arrows, let's just go back. Now, since the arrows are pointing upwards, it means this part in front is removed and the back part is left behind. If you look from a top view perspective, we're not going to draw it from a top view, but just so you get the idea. Vertical lines. This is also important to note. Show 3 faces of the M24 nut. We'll get back to this. And then luckily, no hidden detail. All right. Now, a new thing that you also have to start doing for mechanical is you need to do some planning. This planning will help you to finish the picture quicker. So the first thing, they want only one view, the front view. So that means they gave us too much information, which they may do. We don't have to use all the information. So we don't need to use the top views, but they are there because we need some of the measurements that might not be available to us on the front views. But what I then usually do is I just take a color or a pencil and just lightly cross out the views that I don't have to draw. Okay, so that I don't get confused between which one I have to draw. So this is part of my planning. This is not something you have to do, but I recommend it. So for every single component, I'm crossing out the parts I don't have to draw. Yeah, I don't have to draw that part. The grub screw, don't have to draw that part. Don't cross it out too much because we still need the measurements, but you don't need to draw it. This part we don't have to draw. We only need to draw the front view of the bracket. And I think that's it. Okay, that's the first thing that I do for planning. The second thing for planning is to plan out how you're going to cut this picture. Now, what we mean with cutting is that since we're going to section this view, we are going to see some of the components on the inside of the drawing. Now, how we demonstrate that something has been sliced open in EGD is what we call hatching. So it's lines drawn at an angle. Let me just quickly get the memo so you can see what I mean. So I'm going to get the memo of this drawing just to show you how the end results will look. The end result will look like. 7. Here we go. Okay, I just will have to pick it up. It's a bit too close. So let me just focus a bit. So this is how our drawing will look like at the end. So we're not there yet. I just want to show you. So this thing is cut in half, and those lines, all these skew diagonal lines, represents hatching, how the blade passed through this object. But you'll see some of these components are not hatched, and there's a reason for it. There's a rule. We do not hatch usually a shaft, the bolt, the nut, and any support structure, but we'll get back to this. So there's the final image. So you know what we're drawing, what we're working towards. Do you see how big it is? Okay, so if I zoom out, look how big it is on your A3 page, just because the scale is 2:1. Okay. Now back to the drawing board. So the next step I always do is I always first determine for myself which view belongs where. And then next thing is, what do I need to cut and what don't I have to cut? So what doesn't need to be cut at all or hatched? So for the nut, there's a rule. We don't cut the nut, so I'm going to encircle it. It's going to stay. So if you redraw it, even if there's a blade, if you pretend a blade passes through it, you leave it. Same thing for your washer. You don't cut it. This is very important. You'll see on the picture. But a bush needs to be cut. The general rule that I always remember in my head is, why are we cutting in the first place? Because we want to show someone what's going on inside the machine, because that's the idea. But think about it. What's inside, let's say, the shaft? Just more metal. There's nothing more to show. So that's usually the rule I remember, with the few exceptions like bolts, washers, and support structures. So that's always what I remember. I think they're testing the security alarm. Okay. So for the bush, your hidden detail acts as the guide of how to cut it. So what I do is I take a different color or pencil, and I just quickly for myself draw in the hatching. So what I do is, this hidden detail becomes part of the drawing, and that part will be hatched. The other side will be hatched. And then these lines on the inside will fall away. We're only going to draw the outlines and the hatching itself. So that's another rule I remember. If there's, so like for instance, that little line there. That little part of the line there won't be there anymore if you draw it, because we only draw the outlines. And inside this bush, inside the bush, the shaft will fit inside the bush will fit inside the pulley, so it's almost like a puzzle piece that you fit together. Okay, so there's my first component, and I've planned out my hatching. Just quickly freehand, so I know what to do. So I'll recommend, this is a nice step. Oh, this is something nice to follow. Okay, next one. Okay, the shaft itself. Since there's nothing inside the shaft to reveal, it's just a metal piece. We're not going to hatch it, except for this little part here. Why? Because there's a small grub screw that holds the shaft in place so it doesn't rotate. They do this sometimes. So otherwise, this component, your bracket, is going to swivel around as well. So this is to keep these two components from turning. So basically, the grub screw will fit in here, if I draw it quickly. So there it is. And then what you do is they call this partial sectioning. You take a freehand, and in that part there alone will be hatched. The rest is the same, just that little part will be added. Okay, done. Are we going to hatch the grub screw? No, because what's inside a screw? Just more of the screw. There's nothing else to show, so we're not going to cut it. Let's go to the bracket. And the bracket actually makes it easy to see how we're going to cut it. There's a hole. Why do you see double lines? Because the outside two hidden detail lines represent the hole itself, and the lines on the inside represents the threading. So there will be some kind of bolt that will screw into this component to hold it in place. But we only care about the outside. Oh no, we care about both. I'll show you what we're going to do. Okay, there's a hole. This is where the grub screw will fit in. And then there's a big hole here where the shaft has to fit in. And when we add the hatching, there we go. Okay, one more component to plan, and this one is a bit difficult just because there are so many lines. The pulley. Okay, bear in mind, or just bear with me. Remember, because we're going to cut this thing in half, a lot of these lines on the inside won't be there anymore. Okay, so I'm going to follow the hidden detail again as a guide. Oops. Now, I'm going to start hatching it. Remember, this is just our planning. We haven't even started. By the way, the rule for myself, as soon as hatching goes over lines in the middle, those lines won't be there anymore. Let me just show you in on the memo again what I mean. Okay, do you see? There. That's that same part. You see, you only see the outline, not all those lines on the inside. Okay, so compare, look at all those lines. Now you only see the outline of the pulley. So it looks a bit simpler without all those lines. Okay, right. We do not hatch this part. Yes, this part is cut as well. But if you look from a top view, it's a support structure. Let me go to the 3D picture. That wedge, the purpose of the wedge is to hold the outside pulley and the inside part of the pulley together. And if you cut the wedge in half, what will you see? Nothing. It's just more of the wedge. But the rest of the pulley has to be cut in half so we for instance, can see the shaft in the middle, because that's the idea. We'll see this as well. We're going to see this as well. We won't cut it because it's at the back of the pulley. Go back to the 3D picture. So if I cut it there in half, this is that part there. And then that groove there, that edge is what we see there at the back. Okay, so this part will be hatched and all those lines fall away. This part will be hatched. This is cut but not hatched. And here we go. This might feel overwhelming. That is why we're starting with this in the beginning of the year. You have enough time to practice this, so don't worry. This won't be something that you're going to write test about tomorrow, or for the first month. So just start. So like I said, if you mess up this drawing, it's fine. It's about learning. And if you still struggle, then we'll organize some extra classes a bit later in the coming weeks. Okay, so there's my planning. Now I'm actually ready to start. This took a while because I had to explain, but this should take you not more than 5 minutes in a test. Okay, this is just to plan out your picture. But I guarantee if you plan your picture out before you start, especially how you're going to cut it, it will save you a lot of time and headaches later. Okay, now let's go to our blank picture. What I want to say is, how you're going to, you can choose which component you would like to start with. What I've learned over the years, it's the easiest for me to start with the shaft itself because everything else fits onto it. So it's almost like the center of the entire shape. So I usually start with this guy. So I'm going to start off component 7. But you could have started with the pulley, for instance. That doesn't matter. Okay. All right. Okay, here's our next problem. In front of you on page 7, we've got a blank page. Where do we start? Do we start there? Where do we start?
So we start with the 60 and 30 lines.
60 and 30 lines, yes, but the question is, where do we start? The answer is...
On the paper.
On the paper, yep, but where? Where on the paper?
So you have to draw those things so you know where to start.
Oh, no. You're thinking about isometric. No, we're going to draw this flat. You'll see now what I mean. This is flat, two-dimensional.
Okay.
Since we're only drawing the front view, we only have to draw one component. We're going to draw it in the middle. So there's enough space this side and this side. A good way to check that your picture will fit is, since the shaft will represent the highest point, you take that measurement, 82. And, oh, wait, I forgot something. Guys, before we continue, the scale is 2:1. So quickly take your calculator and work out all the measurements. So what I do is I cross it out.
You double everything.
Double everything. Otherwise, you're going to, after a while, forget about the scale. And then you're going to have like this weird big shape, small shape. So quickly, before we start, take your calculator and multiply all the measurements. I know it's a lot of measurements by 2. Okay, so let's quickly do this. I'm going to do it as well. And then we will continue. We just... So you can see what I'm doing. Okay, so let's quickly just double all the measurements. So you see, I think there's a question here. important, degrees. Don't double the degrees. Your degrees stay the same. It's just a measurement. So any degrees like 30 degrees, that stays 30 degrees. I know it sounds like obvious, but sometimes you're on such a roll, doubling everything, you double the degrees as well. So it's to keep that. So it says here at the shaft, 30 degrees charm. That's the bottom part of this grub screw that stays 30 degrees. Let me check if I missed anything. Now, again, this might feel like a lot of work, but there's nothing as horrible as drawing a picture with a scale, and then somewhere halfway along your drawing, you forgot about the scale. And now you have this weird, big, small part and nothing fits together anymore. It's horrible. So play it safe. Add the measurements before the time. If there's a scale, anything else than 1-to-1, to save yourself a lot of headaches later. Just want to get this a bit closer. Okay, I'm going to put my question paper just here at the top so I can just still read it. Now we're going to start. So, like I said, the middle is the best place to draw this picture. Let's say in the future we have two components we have to draw, a front view and a right view. Then the front view would have been here and the right view would have been here. But since we only draw one component, planning for space is not that crucial. But when we get to two pictures, we'll discuss that. So I'm going to start here in the middle somewhere. Not exactly, just plus minus. But what I'm going to do is I'm going to start closer to the bottom, drawing upwards, since the shaft, if you look at your page 6, is the lowest point in that assembly line. Okay. So I'm going to start. Now you do this as the Afrikaans saying goes, I think it's an English saying as well. To eat an elephant, you eat it piece by piece. You're not going to swallow the entire elephant at once. The same thing with mechanical assembly. One part at a time. So I'm going to start with drawing the shaft. Okay, so I'm going to look at the shaft. I'm going to now focus on this part there. Use the measurements and then draw that entire component. What you can, however, do is just don't make that part there too dark yet. We have to add the grub screw afterwards. Okay, so the rest you can darken already and complete and draw it exactly the same way. Just that part there I want to show you. I'm going to zoom in closer because I'm only going to draw on a small part and I'll move it around as I'm focusing on different parts of the drawing. Pro tip from for you guys, since the shaft needs to have a center line, if you look at the picture, I'm going to draw the center line immediately because I always forget to add the center line when I was at school. Like I always forgot, and I always lost marks for center lines. The center line. It's about 10 minutes. I'm looking now for how big the shaft is, and where you'll get this answer is from its top view. So it's 24. Oh no, sorry, I'm lying. It's not the 24. Where is the size of the shaft? Then it should be probably on the pulley. Oh, here it is. Since the shaft has to fit inside the pulley, no, that's the bush. So let me say it again. Since the shaft has to fit inside the bush is the size of what the shaft should be. So it is it 40? Just want to check, is it 48? Yes. Okay, so the diameter of the shaft is 48. Six. Okay, it's almost time to take a break before the second period starts. Let's just quickly discuss the grub screw that has to fit into your shaft. I'm going to leave this at the top like this, like it is for now. I'll add all the detail at the end. Let's quickly talk about the grub screw. So the grub screw has to fit in here. According to the measurements, it goes 30 millimeters up, and this is the center of your grub screw. So move this up a bit. Okay. it's said here that the angle of the screw is 30 degrees. So that means if it's 30 degrees, but now it's at a 90-degree angle, so you can use your 60-degree angle. But first, just draw the grub screw itself. So it's 18. Okay, so here's the grub screw. And now what you do is to add the hatching, you're going to draw a freehand squiggle, just like this. This is fine. And you're going to take your ruler. I'm just going to turn it this way so I can fit in my ruler actually. And now you just add your hatching. Okay, so that's how far we are with the drawing, or that's where I am. If you're following along, oh, I forgot about the little part here at the top of the grub screw. We'll do it when we come back. Okay, you can quickly take a break, and then we will start at, I'm going to check when this last period started, at 13:20 again. Because it's 20 past 1, you can quickly stretch some legs. Before we start, when we come back to Zoom, I'll post the link again. Then I'll just quickly open the floor for some questions up until this point. Then we will continue from here. Okay, guys, see you in the second period. Take a quick breather. See you soon. Quickly record it. There we go. Okay, so how to get the gap from, how did I get the gap from there to there? The complete distance or the total distance is 64. If you half it, it's 32. Okay, that's the one part. And then this shaft here has a radius of 48 because 24 times 2. Okay, it's 48. So it's 32, half of 48, which is 24. And the difference between 32 and 24 will give you that distance there. All right, is that fine? Let's just open the floor for any other questions. I'm just reading the messages on the group. Hi, sir, my wife is really bad. Yeah, that's horrible. Okay, yes, I am recording. That's brilliant. Okay, any other questions before we continue about the work so far?
Sir, how do you know how long I can't think of the name of it now. The thingy that we drew, the last thing that we drew. How long do you know that's supposed to be?
The grub screw from there to there.
Yes, sir.
Yeah. There's the distance. So from.
Oh, okay.
There you go.
Okay. Thank you, sir.
Don't worry, someone else might have missed that as well. Someone else who has a question? Okay, let's continue. Before I leave the grub screw, because it's almost done, what I forgot to add is there's a little gap at the top where you can use a screwdriver to tighten the grub screw. And then also the grub screw is also a circular object if you look from it from a top view. So we have to add center lines again. Okay, and then that little gap, it's 4x4. No, not the vehicle, as in 4 millimeters by 4 millimeters. Okay, there we go. But now I've got a problem. That line is there. But if I take my eraser, it's going to rub out like half the page or half the grub screw. So what I recommend you should get for yourself is get yourself an eraser shield. So now what you do is you line it up with one of the openings that should work. That should be fine. No, maybe this one. Use. Yeah, that should be fine. And I protect most of the drawing so I don't lose too much time trying to erase stuff and redrawing it. If you're wondering why it looks a bit smudged, that's because I've got a dirty eraser. So make sure your eraser doesn't look like this. That's horrible. Okay, clean eraser helps for clean drawing. Okay. That was the shaft. I'm going to leave this here because I also have to add the bolt and, the nut and the washer. So I'm not going to do too much for now. I'm just going to continue with the drawing. Okay, the next part that has to be added is this bracket. Oops. So we've got this. I'm going to add the bracket now. It's this guy here. There. Okay. So now let's add the bracket. The bracket. Okay, what's the height of the bracket? Just want to quickly check something. 32. Do you see something? If you look at the measurements, the gap between this and this is 32 if you look at it. And the spacing here is also 32. Well, that's before we worked out the scale. So it's 64. So that means the shaft will fit in there nice and snug. So this bracket will stick over the shaft itself. So you'll see now what I mean. 38. .108. So that's 54. I'm going to zoom out a bit so you can see the whole bracket. So the complete distance is 92, so it's 96, 192. Okay, there's the bracket. Now I'm just going to add the hatching. Now the rule about the hatching is the angle and the spacing doesn't matter, but it should look different. Every new component that's hatched should look different. And then usually my rule is the smaller, the closer the hatching together, the bigger, the wider the gap between the hatching. Okay, there we go. So we've got the grub screw. We've got the bracket in place. I just think I need to darken this tiny bit more. Okay, so just want to check if I missed anything about, oh, I did. Guys, what did I miss? I forgot about the holes. Oops. Okay, that's not too bad. It's likely just a bit of hatching I'll have to erase. I completely forgot about it. Now there's something about the threading I want to show you when we get to these holes in the bracket, but we'll get there now. 16, so it's 8. Now I just need to erase that. See if this side is a bit cleaner. Okay, now something about the threading that we have to talk about. As you can see, there are 2 lines of hidden detail at the holes, because what they did is they put in threading, what it's almost like a groove for screws to turn, not screws, sorry, bolts to turn into, like our grub screw. Now, because the grub is already in there, we don't have to show it. But since these 2 holes are empty according to the drawing, we have to show that threading. So what I mean with this is, at this hole here, we're going to add threading on the inside. And I just want to check what is the, yeah. Now, I'm going to teach you a bit of calculations. The grub screw has a metric diameter of 18. So if you want to work out the smaller circle, what you do is you take 18, you times it by 0.1. It's always 0.1. So if you want to work out the threading of an M value when it comes to bolts or nuts, it's always times 0.1. And 18 times 0.1, you basically just move the decimal 1 space. So you get 1.8. Now, we can't work with 1.8 because to try and get 1.8 on your ruler is quite difficult, because there's 1, there's 2, so 1.8 is somewhere there. How on earth do you get it? You can't. So we round it up or down to the nearest whole value. So 1.8 is closer to 2. So we're going to work with 2. So 2 millimeters. So what you're going to do here on your page, we're going to add 2 millimeters. We're going to add the threading. Okay, and then what you're going to do is, oh, sorry, you can't see it. There we go. So you're going to add the threading. And then the only rule here is that the threading itself is, the gaps between is also hatched to represent that it's a hole. But because my hatching is so big, you won't be able to see it. So it's just going to look like 2 double lines. So that's the complete hole. And then that represents the groove on the inside of the, to show it. I'm going to quickly go and get an example, a physical example from a class at the back, just to show you what I mean. Okay, so here I have a bolt, nut, and a washer, an example of them. Now, if you look at the bolt, there's threading on it. It's like a pathway or a groove so that the corresponding nut can actually rotate into it. Okay, so what I'm doing now represents what the grub screw is doing to the shaft. It has been turned into the groove, into the threading. But this hole here is almost like this nut here, an empty hole. But if you look carefully, just get closer. If you look inside the nut, there is threading where a bolt can slide into. Now, in this picture, we do not have additional bolts to draw, but we still have to include the threading to represent it. That is what that extra line represents. And you work it out by always taking the M value and times it by 0.1, which basically means move the decimal to the left side. Now I just want to do just want to draw it on the other side as well. So here's a good example. Since it's an empty space, I can actually add that bit of threading again. I'm hatching, so wrong one. There we go. So it will be here, but not in the space there. So this shows you that the threading, there's nothing inside this hole that has threading. It's empty. So then you just hatch over it. Okay, we've got time just to include the bush. Let me just show you because that's then the time will be over. So check. Bracket is done. Now for the bush. And then we're done for today. Okay. they don't directly give the height of that little line there. But if you look carefully, the complete height is 74 and that part is 66. So to get from 66 to 74, that's 8. So then we know the height is 8 millimeters. Now I just want to hatch it and then we can call it a day. And there we go. So this is how far we got with our page 7 of mechanical assembly. We have done the shaft or partial. We have finished the grub screw, the bracket, and the bush. Then tomorrow we have to add the pulley, the washer, and then I'll show you the construction of how to draw the nut. There's a certain recipe. Are there any questions at this point in time before we end our class? Just want to give a few more seconds. Okay, good. Guys, I'm going to then stop. I'll quickly process these videos. Well, not quickly. I'm going to process them and then put it, send you the link so you can see today's class session. And then we'll see each other tomorrow. Thank you for participating. And we'll see each other tomorrow. Don't be alarmed if this is still scary and new. This is your first page. Roll, make the mistakes, but enjoy it as well. Thank you so much. And we see each other tomorrow.
Bye, sir.
Bye, sir.
Bye-bye. Bye-bye.